Wonderful. All right, welcome everybody. Thank you for being here. My name is Elena Luchkina. I'm a postdoctoral fellow at Northwestern University. And so today I'll be talking about my work on the development of verbal reference, and specifically about how babies learn words for things they've never seen. Now, the human mind is incredible for its flexibility and power. As humans, we can call to mind objects, events, and ideas without witnessing them directly. For example, we can talk about the time that hasn't passed. We can talk about abstract physical phenomena for which we have no faculties, to experience. And we can just talk about things we haven't encountered, like novel animals and people we haven't met. Now, following the work of many of my colleagues, I propose that this incredible ability is brought by verbal reference. So it's enabled by verbal reference. And here I define it as a three-way referential link between words, their reference, and mental representations of those reference. And in particular, the word-to-representation component of this link is key to our ability to engage in communication about the unobservable things and abstract things. And importantly, this link allows us to not only retrieve or modify existing representations, but to form entirely new mental representations based on language input alone. And of course, the big question is how and when does this link emerge? Now, in this presentation, I will show you that by 15 months, infants have begun to establish this link. But before we get there, how does one even test verbal reference in infants? And here's the challenge. In the majority of word learning studies, the novel word and its referent are co-present both during learning and during test. And this means that if a baby, even if the baby orients to the correct object upon hearing its name, looking to it or touching it, it's relatively weak evidence for the link between a mental representation and a word. And so clearly, the object and the word must not be co-present, but how? And before I give you our answer to this question, I just want to quickly review what has been done before. So most studies to date address this problem that I just described by either presenting words in the absence of objects or objects in the absence of words during test. So for example, in one widely used design, a baby would be shown an object, like this is a DAX, then the DAX goes away, the DAX is hidden, and after some delay, the baby would be asked to locate the DAX. And then the baby's search behavior and gaze behavior pointing will be measured. So here the object is not present during the test, just the word. And alternatively, babies would first hear a word and usually embed it in some kind of story, say a story about a bicycle, and nothing would be shown, no objects at that point. And then during test, they would be shown an object from the story, like a bicycle, and some unrelated distractor objects in silence. And at that point, their looking behavior is measured. So if they look to the right one, then presumably they have successfully retrieved the representation of a bicycle when they heard the story. And so let me just quickly show you what studies that use those designs have accomplished so far. So we know that by about 12 months, infants begin to show the first signs of something called absent reference. Absent because the objects are absent, so hence absent reference. But at that point, it's fairly fragile, so it requires some sort of perceptual reminder about the object. For example, the container that used to contain that object. And those are called anchors. So hence anchored absent reference. By 14 months, however, the infant's comprehension of such reference becomes a little more robust, so they no longer rely on anchors quite so much. And they also begin to incorporate social information, such as the experimenter's history of interacting with an object, when interpreting such requests for objects that are absent. By 16 months, infants begin to retrieve and modify existing mental representations based on language input alone. And finally, by 18 to 22 months, depending on a study, infants reliably form new representations based on language input. And so this reviewed literature tells us quite a compelling story. So from this evidence, we can infer that infants begin to form this referential link between words and mental representations somewhere between 12 and 18 months. But there is a nuance. And so notice in the designs that I described to you, word referent pairs were learned in the presence of the referent, and they were only separated during test. And so that makes it somewhat unclear whether those studies really test reference or access to a representation through a word. And here's what I mean. If we hear a sound of a flute, we can retrieve the representation of the instrument, but we don't necessarily perceive those signals as referential. And so that poses a bit of a problem. So what we really are dealing with is that the onset of this referential link between words and mental representations and its unfolding remain at least underspecified. And so what we need is a task that would explicitly link words with mental representations at the time of learning. But then the question is, how do you plant a mental representation into the mind of a prelinguistic baby without showing the object? Well, I'm going to show you how we approach this problem. So we designed this entirely new task specifically for pursuing this question. And so what we want is to introduce a novel name for the referent while it is invisible. And to make this task possible for infants to learn a name for something that's invisible, we leverage their sensitivity to semantic priming. So here, first, I'm going to show you our main condition of interest, which we call semantic priming condition. So just to orient you, we have two phases in this study, the priming phase and the test phase. And so what happens during the priming is that it's all shown on video. So the experimenter first introduces and labels 3 familiar to the infant objects. And the trick here is that the objects sort of pop up behind her back. She will notice and be like, oh, an apple. Do you see the apple? And then it happens with 2 more objects. And so you can notice here, all these objects come from the same semantic neighborhood, in this case, fruits. And then by the time she comes to labeling the 4th object, she does the same thing. She notices that something behind her back, turns to look at it and labels it, but it just so happens that she occludes the object entirely by her body. And so the baby cannot see the object. But what we're hoping is happening during this event is that babies infer 3 things. 1, there is something behind the experimenter's back because 3 times something was. 2, it's probably a fruit or something of the sort, something maybe edible, because the first 3 were. And 3rd, she is labeling it. When she says, look, a modi, can you see the modi? That's the labeling event. And if we're right, when we get to the test phase, babies should prefer to look to this object that looks like a fruit. We hope that they've never seen this kind of, never seen this kind of fruit. And then we have a perceptually matched distractor object from a semantically distant neighborhood. And then we have a control condition in which we just want to make sure that babies don't just prefer to look at fruits, or they just like our object on the left a little bit better. So here we call it the no priming condition, and the only difference here is that during the priming phase, the first 3 objects, the familiar objects, are from semantically distant areas. We have a hat, a truck, and a horse. And so the baby should have no particular idea about what that 4th object might be. Oh, and by the way, I should mention Anne Christophe. This object popping up behind the back was inspired by one of her designs, so just wanted to give her a shout out. Now the results. Okay, so we first conducted some preliminary analysis, found no effect of semantic neighborhood. We used fruits, animals, vehicles, clothing. That didn't matter. We did have a significant effect of age, and I will show what it was in just a moment. But our main analysis showed a significant main effect of condition. So here we have our semantic priming condition in green, our no priming condition in red, and on the y-axis we have the net looking preference, net because we subtracted the looking preference before the verbal prompt. That's why it goes below 0 it can go below 0. And so here we see the significant difference between the conditions. And after we conducted some exploratory analysis to just take a look at our significant effect of age, we found that the effect of condition was mainly driven by the elder half of our sample. So the younger ones were for around 14 months, the older ones were around 15 months. And now let's just take a look at the trajectory of infants' net looking preference, and that will just give us some additional insights about infants' reaction to hearing the target noun. So here again, in green, we have the semantic priming condition. In red, we have the no priming condition. And you can already see that at least the older infants show this noticeable divergence between the looking trajectories upon hearing the target noun. And we conducted cluster-based permutation analysis to analyze this divergence. Ask me later if you would like to know more about cluster-based permutation analysis. But what we find is a significant cluster of divergence between 3,000 and 4,200 milliseconds. And interestingly enough, we have this consistency with a different study from our lab that also asked infants, but slightly older infants, 19-month-olds, to learn a meaning for a word, the meaning for a word for the object they've never seen based on sentence context. So that's just an interesting consistency here in the timing of divergence. Now, as these results would suggest, at least the older infants in our sample successfully formed a representation of an object they haven't seen and learned the name of that object. But you might have a concern, at least we had a concern, about interpreting our results. And here what it is. What if infants that have seen 3 fruits are now all about fruits? They would like to see another fruit and they don't care about its name. Right? So to address this possibility, we designed another condition. And it's almost identical to the semantic priming condition, which you see displayed. You've seen this already. Except that we switched the word during test. So they learned the word Modi in relation to this novel object, but we're asking them for a blicket at test. And so if it was not about the word, then their looking pattern should be identical in the semantic priming and in this, what we call switch word condition. But that's not actually what we find. So you see that the switch word condition is quite different from semantic priming. I should mention this difference is actually not significant. So it's possible that, this priming procedure alone may play some role in guiding infants' looking behavior, but it's unlikely that it accounts for the entirety of that looking preference. And again, the time course will tell us a bit more. So this is what you have already seen. The green is the semantic priming condition, the red is the no priming condition. And now in blue, you will see the switch word condition. Okay, again, I'm not sure what's going on with the younger ones, but if you take a look at our older infants, you see that the blue line falls just between the other two, the red and the green. And so it's not, so it kind of tells you that it's not to say that the priming alone does nothing, but it doesn't drive infants' looking preference quite as high as the semantic priming condition. And actually, we found an almost significant cluster of divergence. The p is 0.06. It's a little bit later, but in general in the same time frame as the other cluster. You see that, I don't know if you can see on that chart, but the clusters overlap. Right, and so in total, what these data tell us is that by 15 months, infants can establish a representation of a novel object without seeing it based on our priming. They can link it to a novel word, so they learn its name. And they can identify that object when it becomes visible. And so that means that by 15 months, infants already possess this referential link between words, reference, and mental representations. Now, what are we going to do next? Well, first, we're going to take a look at even younger infants. Remember, I told you that by 12 months, they begin to understand something called absent reference. And so it's possible that even 12-month-olds might succeed in our task, but it's a pretty demanding task. And so they need to know all these words and all these objects. And so for that reason, we're actually giving them a week long of picture book training before running them through our task. And we're almost done with data collection, so please stay tuned. that we actually have a registered report that will turn into an actual paper pretty soon. And then, more importantly, we would like to evaluate the effects of having developed that link. Remember earlier, I told you, I think that that's the key for language-mediated knowledge acquisition. This is what we need to learn information from language. And we would like to test that. So one way to test it is we want to know whether the variability on our task at 15 months would predict variability on learning from language later on in a few months. So we're going to test 24-month-olds. And we would like to know if this link between words, mental representations, and reference has a broader impact on infants' abstract reasoning skills. And finally, of course, we would like to know what are the mechanisms that give rise to this referential link between words and mental representations. And by the way, I suspect it's social contingency. So just to connect it to our previous talk. So please stay tuned as well. And on that, I would like to thank our families that participated in the studies, our funder, and the members of the Northwestern Infant and Child Development Center. Thank you.